So we are talking about volume, and in the warm-up, so we're talking about volume, and we're going to specifically talk about the volume of a cylinder, a cone, and a sphere. So when we're talking about these three shapes, I want to specifically talk about what we know about shapes and their volume that you've already learned, maybe like in 5th or 6th grade. So we're going to talk about a prism, and we find the volume of a prism. Now the volume, if you remember, is all of the inside stuff of a 3D shape. Okay, so it's how much can fit inside of a 3D shape. So the volume of a prism, if you remember, is length times width times height. Okay, so when we do length times width times height, length times width, this part right here, tells us the area. Okay, and that's the area of one of the faces. The rest of it is just the height. So imagine if we were to take, I'm going to draw one up here if you can. Hopefully this works for the most part. You can get the idea. This is a really, really, really bad prism, but okay. So here's my prism. Length would be this guy. Width is going to be this guy. So I want you to imagine that we have a bunch of rectangles, flat rectangles, that we're going to stack on top of each other all the way up to the top of this box. Okay, so we're going to lay flat some rectangles that are going to lay flat into this box. So it's the area times the height. So it's area almost times the height, which is kind of like how many I'm stacking on top of each other. Then the volume of a cylinder, so we're changing, the only thing we're changing from a boxy prism to a cylinder, this shape right here, is the fact that the base is a circle. In the area of a circle, we're still going to do this exact same thing. We're going to do area times height. But instead, the area of a circle is pi times r squared, still times height. So the volume of a cylinder is pi r squared h. And all you're going to do is multiply all of those numbers together, and that's going to give you your volume. Now we're going to move on to a cylinder, or excuse me, a cone, using our knowledge of a cylinder. So we already said that the volume of a cylinder is pi r squared h. Now, I'm going to fill a cylinder with water, and how much do you think of the cone it's going to fill? That has the exact same height and the exact same base, so the same size circle as the base and the same height. When I fill this cone, it's going to be exactly 1/3 of our cylinder. Okay, so that means I took pi r squared, my cylinder, and I'm going to divide it by 3, and that's going to give me the volume of one cone with that exact same height and radius. Okay, another way that you might see this is 1/3 pi r squared h. Now, these two are exactly the same. Okay, this formula pi r squared h divided by 3 is exactly the same thing as 1/3 times pi r squared h, because dividing by 3 is the exact same thing as multiplying by 1/3. Okay, so now we have 2 of our 3 formulas, and the last one is a sphere. Okay, now notice that a sphere has no flat faces on it, like a cylinder or a cone. A sphere just rolls. Okay, so there's going to be no height in this formula, but we are going to have only a radius. Okay, and remember, in a circle, that's more of an oval, but in a circle, you can have either a diameter, which I'm going to label D, which goes all the way across the circle from end to end, or a radius. A radius goes from the middle of the circle to the edge of the circle. If I give you a diameter, the diameter is going to be 2 times the radius. Okay? So if I give you a diameter, let's say a diameter of 18, then that radius is actually going to be 9. Okay, it's half of the diameter. Okay, so volume of a cylinder, again, is pi r squared h equals volume equals V. Okay, and what that's going to tell us is that we're not going to use height, but instead we're going to use just a radius. Now, I want you to think about the fact that the radius is being counted twice. So I want you to think about how many dimensions or side lengths am I using to measure this? Well, I'm using radius, that's 1, times radius, that's 2, times height, and that's 3. So I'm using 3 dimensions here, 3 side lengths. So that means if we're taking out the height, how many times am I going to have to multiply the radius by itself? Well, 3 times. Still going to have pi. And actually, if I were to fill this sphere with the same radius as the cylinder, it's going to take about 4/3 of the cylinder to fill up the sphere. Okay? And remember that 4/3 is equal to 1 1/3. So it's going to take about 1 1/3 cylinders to fill up the sphere. Can't remember if I have a slide after this. Oh, good, I do. Okay, so let's do a couple practice problems just to see if we can get the hang of this. So, I have given you a cone, okay, and remember that the cone is pi r squared h divided by 3, because remember when we filled up that cylinder, or filled up the cone with using the water from the cylinder, it took 1/3 of the cylinder to fill the cone. All right, so here, this part right here is my radius, because notice how it goes all the way around the circle. Well, that is not good tracing, but the radius is 12 miles. Okay, and I'm getting my measurements right here. And my height is 24 miles. Okay, all I've done to this cone is just laid it on its side. So if I were to lay it straight back up and it was going to sit on the bottom, on the base, then my height would still be from top, from the point, down to the bottom. Okay, so now what we're going to do is just plug these numbers into my formula. So pi times 12 squared times 24 divided by 3. And what I want to make sure that you guys do is that you do this part first, then divide by 3. Okay, I don't want you to get things mixed up. I don't want you to miss a problem because you're doing it in different orders. Okay, so all you're going to do is multiply all of these together. These little dots just mean multiplication. Okay, so pi times 12 squared times 24, all divided by 3. Is going to give us a grand total of 3,619. And let's round to the hundredths. And so I'm going to round to 1, 1. So 11 hundredths. Then, can't forget my units, miles cubed. And the reason that's miles cubed and not miles squared or just regular miles is because we are working in 3 dimensions. Okay? All right, now let's look at a cylinder. So same thing here. We're going to use the cylinder formula. Okay? And the cylinder formula is pi r squared h, not divided by 3 because it's just the full thing. My radius is this guy right here, 3 yards. My height, h, is 5 yards. Now I'm just going to plug these straight into my formula. Pi times 3 squared times 5. It's going to give me a grand total of 141 and 37/100 yards cubed. Whoops. All right, last one, we're going to do a sphere. I'm going to do a sphere that has the diameter instead. So notice that this red line is the diameter. Okay, so the diameter is 24, but that means that my radius is going to be 24 divided by 2. So my radius is actually going to be 12. Remember that the sphere volume formula is 4/3 pi r cubed. My radius is 12. Don't forget that in this formula it's different because you are cubing the number rather than just squaring it like the other two formulas. All right, so I'm going to multiply all of this together, and it's going to give me a grand total of 7,238 and 229 thousandths, but this 9 is going to round the 2 up. So it really is 7,238 and 23 hundredths. Move this box. Yards cubed. And there it is.